AI 啊，还是真人的？
真的没？
不知道。
应该是比较像吧。
SPM上面，这里。
为你举个地方。
哦，有。
去买
小笔。
没有。
哦。试用做FIP。
有比较好吗？还是一样？
好处是可以直接拖 PDF 进去。可以直接拖 PDF 那些进去。就这样吧。讲比较聪明也还好。因为我 FIP 说不出来。
最多一个 feature 吧。那 feature 很废。
我很想像那个 C 的，然后 C 没有，我就想拿这个猫，拿这个猫也没有，然后我就直接很笑，2点，然后很早很早就没有了，对，很早就没有了，对，然后我就问他有什么，然后他跟我讲。spaghetti 那些，还有那个，一时没有脑筋死了。我也是有东西。
给他拆没有？
现在太多晚上。
带回家。
你要去给进门按
要。
ABC。
Okay, class attendance. For your information, this chapter there's a version 2. So version 2 I already uploaded to the Google Classroom. Okay, take your attendance.
有没有读？有没有？
考试在。
Okay, so today you will learn software metrics and measurement. Alright. So there are 4 parts here: introduction, software metrics, software measurement, and metrics for software quality attributes. Okay, so for software quality, okay, so you want to know software quality. Okay, what are the things that you can measure? Okay, so that you know whether quality is good or quality is not. So first of all, as you can see here, I've underlined 2 words. Okay, metrics and measurement. So it's good that you understand these 2 terms. Okay, so what's metrics and what is measurement? Alright. So metrics is the quantitative measure of something. Okay, so I repeat, metrics is the quantitative measure of something. So something can be a project. Okay, so you can quantitatively measure a project. Example, for project A, you can measure total lines of codes. For project A, you can measure total pages of documentation. Okay, also number of defects reported by customer 1 week after installation. Alright, so these are some of the things that you can measure quantitatively for project A. Total lines of code, total pages of documentation of project A, number of defects reported by customer 1 week after installation. So what else can you measure for project A? Okay, I'll give one example. So you have completed a project A. So you can measure total lines of code. Okay, in total there are how many pages of documentation? So after installation, 1 week after installation, how many defects are reported by customer? What else can you measure for project A? Number of screens, you can measure, right? So project A, there are how many measured screens, you can count and give you a number. Number of screens, number of reports, number of database, okay, so number of tables. So in project A, there are 100 tables, or in project A, there are 200 tables, okay, you can measure. So that's metrics. So measurement. So measurement here says is the act of finding out the amount or size of something. So again here something is project A. So example project A, you want to find out total lines of code. If you want to find out in project A there are how many lines of codes, then you need to count lines of code in each program and then sum them up. So after you sum up, you may find out that total line of code is 10,000. Alright. So counting lines of code, okay, so counting lines of code in every program and then you sum it up is the act of finding out the amount or size of something. Okay, so you have an idea what is metrics and what is measurement. Okay, you have to understand these two terms, if not you will be confused. Okay. So counting lines of code in each program, then sum them up is the act of finding out the size of project A in terms of lines of code.
Yes.
Okay, so repeat. So metrics is a quantitative measure of something. Okay, example A, okay, 25,000 lines of code, 2,000 pages of documentation, 10 defects reported by customers 1 week after installation. So these are quantitative measure of something. So something here is project A. Okay, so for measurement, so measurement is the act of finding out the amount or size of something. So how you find out the amount or size of something, you count. So you count lines of code, sum them up, then you get total lines of code of a system. So you can also count, okay, count total pages of documentation. You can count number of defects reported by customer 1 week after installation. So all this counting is the act of finding out the amount or size of something. Okay, so if you do not manage to write down completely, refer back to Google Classroom. I already uploaded. Okay, notes version 2 is there. I'll skip this one. Okay, I'll skip this one. Okay, so now examples of software metrics. Okay, so examples of software metrics. So for software, what are the things that you can measure? Total lines of code or LOC. Errors, okay, you can measure how many errors you found, how many defects you found, and pages of documentation. You are now doing project 2? No, doing project 2? Okay, those who are doing project 2, can you count? So how many pages of documentation you have produced? Can, correct? So you open chapter 1, you can count. So Word, you don't need to count manually. Okay, so Word can tell you chapter 1 how many pages, chapter 2 how many pages, so total how many pages that you have produced. Okay, so here there are 2 projects. Project A, 306K lines of code, 288 errors found, 30 defects, 205 pages of documentation. And these are the metrics for project B. Okay, so you look at these 2 numbers, 30 defects, 20 defects for A and B. Okay, so you can compare, when you compare these 2 numbers, you can conclude that project A has 50% more defects than project B. So this is how I count. This is how I get 50%. 30 minus 20 over 20 times 100%. Alright. So if you compare these two values, okay, it tells us project A has 50% more defects than project B. So these are metrics. Okay, so these are examples of metrics. These are non-normalized metrics. You can look at the heading here. So these are non-normalized metrics. Okay. So non-normalized metrics show that project A has 50% more defects than project B. So the non-normalized metrics here, if you just look at the defects, it tells us project A has 50% more defects than project B. Okay, so now we normalize the metrics with KLOC. KLOC stands for 1,000 lines of code. Okay, so KLOC means 1,000 lines of code. So these are non-normalized metrics. Okay, so now we normalize the same metrics with 1,000 lines of code. So normalize with 1,000 lines of code means we compare number of errors or number of defects or other things between projects based on per 1,000 lines of code. Okay, so this is what we get. So project A number of errors per 1,000 lines of code is 0.9412. So for project B, okay, so number of errors per 1,000 lines of code is 0.9102. And for defects between project A and B, per 1,000 lines of code, defects per 1,000 lines of code is 0.0980, 0.0781. Okay, so this means in every 1,000 lines of code, project A has 0.098 defects, project B has 0.0781 defects. So based on defects per 1,000 lines of code, project A has 25,000 more defects than project B. So when you normalize with KLOC, so that means we are now comparing, okay, project A, okay, we chop it to 1,000 lines of code. Okay, project B also we chop it by 1,000 lines of code, 1,000 lines of code. Now we compare project A and B based on per 1,000 lines of code. Okay, and see, okay, what are the defects based on per 1,000 lines of code. So why we do this is to make a fairer comparison. Okay, so this is to give a better comparison. You compare based on per 1,000 lines of code. Okay, so project A, in 1,000 lines of code, how many errors or defects? And then for project B, you chop it by per 1,000, every 1,000, how many errors and how many defects. So this will give you a better comparison, a fair comparison, rather than looking at non-normalized metrics. So non-normalized metrics tell you project A has 50% more defects than project B. Okay, but if you normalize it by per 1,000 line of codes, okay, it give you a different numbers. That is 25% more than B rather than 50%. So this is a fairer comparison. Okay, that's why we normalize it with per 1,000 line. Of course, you can normalize it with other kind of metrics. Okay, so you can also count pages of documentation per 1,000 lines of code. So you divide this by this, you will get a figure. Okay, so these are examples of normalized metrics. So you can normalize errors by dividing by 1,000 lines of code, defects per 1,000 lines of code. Okay, so cost per lines of code, pages of document per 1,000 lines of code, errors per segment, lines of code per segment. Okay, so normalized metrics. So use normalized metrics to give a better comparison, a fair comparison. Otherwise, you are not comparing fairly between projects. Okay, so use of software metrics. So software metrics can be used for quality control, project control, productivity estimation, productivity assessment, and also to do estimation. So for software, what we measure, we can measure lines of code. We can measure pages of documentation. So we can measure number of errors. We can measure number of defects. Okay, so these are some of the things that we can measure for software. So for human being, what can we measure? For human being, we can measure height, weight,
BMI.
BMI. BMI is weight over height, correct? I can't.
Power 2. I think it's the height. Power 2.
Height power 2 divided by weight.
Vào đây là
weight divided by square of height. So weight divided by height square.
This one?
Yeah.
Okay. Measure height, weight, BMI.
temperature.
What other things people measure?
Temperature.
Unit temperature.
Okay, temperature. Weight also, right?
Yes.
Weight also. Yeah, okay. A lot of things can be measured for human beings. So software also, many things can be measured. Okay. Alright. Exercise. Usage of software metrics. Usage of software metrics and metrics. So these are metrics. Errors per 1,000 lines of code. Defects per 1,000 lines of code, cost, LOC, and so on. Okay, so you are asked to match usage of metrics to the correct metrics. Okay, so quality control. Okay, usage of software metrics. So what are the usage? To control quality, to control project, example, to control cost, to control risk, to assess productivity, okay, to do estimation. So these are uses of, these are the reason why we want to measure, do measurement, to control quality, to control cost or risk, to assess productivity, whether productivity is high or productivity is low, and to do estimation. So what are we going to measure? What we want to measure, estimate is, for example, to estimate project schedule, to estimate the amount of time needed to complete particular tasks, right? So which one match with which one? Okay, so for quality control, so errors per 1,000 lines of code, defects per 1,000 lines of code, errors per month. Okay, so can be used to measure quality. Okay, so can be used to measure quality, and then so if quality is decreasing, then then you know that you have to do something. Okay. So lines of code per month can be used to assess productivity. Okay, so you measure how many lines of code is produced by a software engineer per month. Okay, so every month you measure. Okay, how many lines of code is produced by a software engineer? January, February, March, and so on. So whether the number is increasing or decreasing. If the number is decreasing, then productivity is decreasing. If lines of code per month produced by a software engineer, okay, when you count one by one, the number is increasing, that can give you an indicator productivity is increasing, right? So others, you do it yourself. So which one match with which one? Okay, indicator. A metric or combination of metrics will provide you insight into the software project. Okay, insight into the software process, project, or the product quality. So when you do measurement, okay, when you do measurement, you get something like this: 500 errors per 1,000 lines of code. So this will give you an indicator that the software is of poor quality. So if you get a number like this, 0.01 defects per 1,000 lines of code, so this number will give you an indicator that the software is of high quality. Okay, so a metric or combination of metrics will provide you with an indicator. Okay, so whether something is good or bad. Okay, let's say Toyota. So Toyota petrol consumption 6 liter per 100 km. Okay, Honda 7 liter per 100 km. So this one will give you an indicator Toyota is more fuel efficiency than Honda. Okay, so this will give you an indicator, okay, in terms of fuel efficiency. Okay, example. So for here, it will give you an indicator. So the number here gives you the indicator. Okay, so whether the software is of poor quality or of high quality. Okay, so come back to this example. So referring to the normalized metrics, normalized with 1,000 lines of code, project A has more errors than project B. So we look at these two numbers here. Project A has more errors than project B. So project A also has more defects than project B. So this gives you an indicator that project A quality is lower than project B. Okay, so look at the pages of documentation. Okay, so project A, pages of documentation per 1,000 lines of code is 0.6699. Project B is 0.7031. So this shows that, okay, so project B has more pages of documentation than project A. So in terms of maintainability, okay, so in terms of maintainability, so project B is more maintainable than project A because project you can find more project information in project B rather than project A. You have more project information. For project B, you have more project information than project A. So this number is greater than this number, indicate that okay, you have more project information in project B. Okay, so more project information is good when you want to maintain a particular system. Okay, so when you want to maintain a particular system, the more information you have, the better it is. Okay, so categories of software metrics. So product metrics, process metrics, and project metrics. So these are the three categories of software metrics. So product metrics can be further divided into two, static and dynamic. So let's look at the static first. So static metrics are lines of code, length of variable names, depth of nested if statement, and cyclomatic complexity. So these are static metrics. So when the project is completed, total line of code will not change. So length of variable name is also will not change. The depth of nested if in the program is also will not change. Okay, cyclomatic complexity also will not change. Okay, so dynamic metrics examples are time required to start up the system. Example, time to start the WhatsApp web. This one means time to start up WhatsApp web. So the time to start WhatsApp web, is it the same every day? It is not the same, right? Sometimes when you start WhatsApp web, sometimes it's faster, sometimes it's slower. So the time to start up the system, okay, is not fixed. It's not the same. Sometimes it is faster, sometimes it is slower, but the program is the same. Okay, so execution time required for a particular function. Okay, so when you execute a particular functions, so the time taken is also not the same. Sometimes it's faster, sometimes it is slower. So example, time required to generate a class code. So I log into the intranet, I want to generate class code. So when I click the class code, sometimes the class code appears fast, sometimes it appears slower. So that okay, so number of system failure. Okay, so number of system failure. So in 2021, you use system A, you encounter 3 failures. In 2022, you use system A and you encounter 2 failures. Okay, so same system, sometimes you encounter more failures in 1 year, sometimes you encounter less failure in 1 year. Okay. But the good thing now, the good thing is we seldom encounter Windows startup failure. Okay, so now seldom encounter Windows startup failure. In the past, I think in 1 year you may encounter 5 to 10 failures in 1 year. Okay, but now this kind of failures seldom happen. Okay, so these are static metrics are metrics that will not change over time, and dynamic metrics are metrics that may change from time to time. Okay, so dynamics metrics can be collected during system testing or after system implementation when you are using the system. Okay, so cyclomatic complexity. Cyclomatic complexity is measure the complexity of a program by counting the number of independent paths through a program source code. Okay, so cyclometric complexity is counting the number of independent paths. If the source code has only one path, then cyclometric complexity is 1. If the source code contains one if statement, then cyclo complexity is 2 because there are 2 paths. So in this example, there are 4 paths. There are 4 independent paths. This is 1. This is 2. And this is 3. And this is 4. Okay. Looking at this diagram, there are 4 independent paths. So more path means. So what does more path mean? More path means. So if there are more paths, that means the level of complexity in the program is higher. Okay, so more path means higher complexity. Okay, and it will be more difficult to test the program. So you need more test cases to test all the paths. Okay, I'll skip this one. Okay, so I've explained to you product metrics. So product metrics, there are 2, static metrics and dynamic metrics. Okay, so now let's look at process metrics. Okay, so for process, okay, so for software process, so what are the things that you can measure? There are 3. So the time taken for a particular process to be completed, the resources required for a particular process, and the number of occurrences of a particular event. So these are for process, these are the 3 main things that you can measure. Time, resources, okay, number of occurrences of particular event. So examples, during testing, 20 errors found. So this is an example of event. So when you do testing, okay, so you do testing and you found out there are 2 errors, 20 errors. And at the design stage, 2 requirement changes received. Okay, so analysis, design, code, test. So at the design stage, you receive 2 requirement changes. It's an event. 50 lines of code modified in response to a requirement change is also considered as an event. Alright. Okay, so other examples of process metrics. Okay, so these are, I just want to discuss a few more other examples of process metrics. So defects delivered to and reported by user. Human effort expended. So you use this particular process to produce a software. So how many human efforts are required? Okay, calendar time expended. You use this particular process to produce a software. How many calendar months are consumed or used? Okay, so time. Okay, so time, hour a day per software engineering task. So when you are developing a software, you have to carry out many software engineering tasks. So on the average, okay, how much time is needed to carry out one software engineering task? Okay, so for human effort expended, okay, so you may want to count number of software engineer required from start to end. Okay, so calendar time expended, okay, you can count number of months used to complete the project. Okay, now measuring project. So for measuring project, you can count total lines of code. Okay, you can count errors found per inspection. Okay, so how many errors found per inspection? Defects reported by customer. Okay, so this can be after the project finish, you install the software. So how many defects reported by customer? Okay, so this can be after 1 week or after 1 month. Okay, so this project, so what's the total pages of documentation? So project duration, so this project consumed how many months to complete? So number of software engineers required to work in the project. So number of changes to the project scope received. So these are examples of metrics collected for project A: 300,000 lines of code, 15 errors found per inspection, 20 defects reported by customer, 200 pages of documentation. So this project A, took 8 months. Okay, so number of software engineer work in project A is 10. So throughout the project, 12 changes, received 12 changes to the project scope. So these are what you can measure for projects. So you can measure for project B, you can measure for project C. So based on what I've highlighted here, okay, so defects reported by customer is increasing. Okay, is increasing from one project to another project. So based on what I've highlighted here, number of changes to the project scope also increasing from project to project. Okay. So when you collect metrics and you do measurement, this is what you can see. Okay, this is what you can see, whether defect is increasing or whether defect is decreasing. Okay, so if defect is increasing, that means your software, the quality of the software produced by your company is decreasing. You have to do something. Okay, so you have to do something so that the software produced by a company is not the quality is not reducing from year to year. You may want to increase the quality. So how to increase software quality? So this tells you quality is decreasing. So if you are the owner of a software quality, what can you do to correct the situation? In chapter 2, you learn about techniques to increase software quality. One is inspection or Fager method. Clean room development. Quality circle. Lesson learned report. Okay, so you can apply some of this technique. Okay, so to increase, to correct your quality problem. Okay. So how to when you look at, you compare these 3 projects, number of changes to the project scope is increasing. Okay. So there are more changes to the process scope as the project progress. So what can you do? Okay, we leave this one. This is out of topic. So come back to metrics. So basically, when you measure, okay, you get insight. Okay, you get insight. Okay, into the quality and other aspect. Okay, so project metrics can be collected from past project, during the execution of current project, or during the progress of technical work. So these are the situation where you can collect project metrics. Okay, so 3 category of project software metrics: product metrics, process metrics, and project metrics. Okay, some of the project process metrics can also metrics for project and product as well. So all these metrics, they are not exclusive. Okay, so they are not exclusive. A particular metrics can be used to measure the product, can also be used to measure projects. Okay, example like lines of code. So lines of code can be used to measure the products. Lines of code can also be used to measure the project. Okay, so to summarize, at first you learn about product metrics. Okay, so for product metrics, software is a product. Okay, software is a product. So for software, what you can measure, okay, lines of code, length of variable names, depth of nested if statement, cyclometric complexity. Okay, so you can also measure system startup time. Okay, so number of system failure over a month or over a year. Okay, so you also learn about process metrics. So analysis, design, code, test, implement. So this is a process. This is the process. So for process, what you can measure time. So time to complete this whole process, or time required to do analysis. So total time needed to do design. So resources required. Okay, example, number of software engineers. So events like errors found, number of errors found. Okay, so number of requirement changes received. Okay, so example here, okay. So for process metrics, so 2 days is needed to do analysis, 2 days for design, 20 days for code, 4 days for test, 2 days to do implementation. Okay, so resources needed to do analysis, 1 resource needed to do analysis, 2 to do design, 3 for coding, 1 for testing, 2 implementation. So errors found during the analysis phase is 2. Okay, 2 errors found during design, 10 errors found during coding, 20 errors found during testing, and so on. So 2 requirement changes received during the analysis phase. Also 2 requirement changes received during the design phase. No requirement changes received during coding. But during testing, 4 requests for changes received. And after implementation, received 6 requests for changes. Okay, so for process metrics, okay, what are the things that we can measure? Time. Okay, so time from start to end, or the time for individual stages. So resources for the whole process, or the resources needed for each stage. Okay, errors found in each stage, total error found from start to end. That's for process. So for project, okay, so for project, we can measure lines of code, errors found per inspection, defects reported by customer, pages of documentation. Okay, so duration, So whether it's days, weeks, or months. So resources required, number of requests, changes received. Okay, so project A, project B. So project A, errors found per inspection 20, project B 10, defects reported by customer, A is 15, B is 10. Okay, so if you look at these two numbers, quality is increasing. Okay, so quality is increasing from A to B. You want screenshot? So this is just a summary. So this is just a summary of what you can measure for products, projects, and process. So the text in black color represent what you can measure. Okay, done. So the text in black means what you can measure. So for process, you can measure time, resources, events. The purple color represent product. So when you do analysis, the product is requirement spec. When you do design, the product is design spec. So coding the product is programs or source code, executable file or system. So when you do testing, the product test plan and test cases. When you implement, the products are changeover plan and training materials. So programs or source code, these are the things that you can measure. So for executable file or system, these are the two things you can measure. So for project, you can measure this. Okay, so when you measure, you may have this number. Okay, so next, size-oriented metrics and function-oriented metrics. So size-oriented metrics. So these are examples of size-oriented metrics are normalized. So lines of code, how many? Effort in terms of month, how many? Cost, how many? Pages of documentation, how many? And so on. So these are size-oriented metrics. These are normalized. This table shows normalized size-oriented metrics. So this is normalized by the normalized metric is lines of code per software engineer, lines of code per month, cost per lines of code. Okay, so project alpha, project beta. Project alpha 134 errors, project beta 321 errors. So if you here you can see it looks like project beta quality is lower than project alpha because it has more errors. But if you normalize it with per 1,000 lines of code, if you normalize it with errors per 1,000 lines of code, alpha they are 11.07 errors, so beta is 11.80. So this like there's a big difference in terms of quality between alpha and beta. But if you normalize it, in terms of quality, in terms of the amount of errors, there's not much difference. So a normalized value shows there is a big difference, okay, in the number of errors. But after normalizing, okay, the errors, the difference in errors is a small difference. So this is a fairer comparison. Okay, so a normalized metric shows there's a big difference in quality. So normalized metric shows there's a small difference in quality. Okay. All right, so for project alpha, 12,100 lines of codes are produced. So project beta produced 27,200 lines of codes. So lines of code per month, okay, line of code per month is alpha is 504, beta is 438, okay. So alpha team productivity is higher than beta team, okay. So looking at the numbers here, after normalize, okay, we can conclude that the alpha team has higher productivity than the beta team. Assuming, okay, so assuming for both projects are using the same language, okay, and both projects, the level of complexity is the same. Okay, so these are examples of normalized size-oriented metrics. Okay, so KLOC stands for 1,000 lines of code. Okay, so when you compare two projects, okay, you make comparison between 1,000 lines of codes. Why they don't compare per 100 lines of code? Can you compare by 100 lines of code? Every 100 lines of code you compare. Why use 1,000 lines of code, not 100 lines of code? Like this one, why per 100 km, per 100 km? Why not per 1,000 km, per 1,000 km? If per 1,000 km, per 1,000 km, the distance is too long to travel to do the testing. If you compare, if you are not using 1,000 lines of code, you say use 100 lines of code. 100 lines of code are how many pages? 2 pages? 3 pages? 100 lines of code is too short. Okay, it's too short. So a better length will be 1,000 lines of code. 100 lines of code is too short. So comparing per 1,000 line code will be a better. It's a 1,000 lines of code is a better size to use when doing comparison rather than 100 lines of codes. So you have to use a suitable size. Okay, so next let's look at function-oriented metrics. So function-oriented metrics measure the functionality delivered by the software system. So if you want to use function-oriented metrics, so first you need to do is calculate function point. So use this formula to calculate function point. So function point is count total times 0.65 plus 0.01 summation Fi. So count total is the sum of all function point entries. Summation Fi is you sum up 14 complexity adjustment values. So there are 14 complexity adjustment value. 14 complexity adjustment value, you sum them up. Okay, so for count total, you sum up all the function point entries. Okay, so function point is count total multiplies 0.65 plus 0.01 summation Fi. So this is how you get the function point count total. So count total is the sum of the count from the following measurements. Okay, so to do count total, you have to count number of user input. So you look at all the screen, you count number of input fields, you count all the clickable buttons. So there is a number of user input. So you also count number of user output. So count number of output fields, count number of error messages, count number of screens, count number of reports. Okay, after you count, you get a total. So also count number of user inquiries. To count user inquiries, you count number of search, you count number of find, you count number of help. So for files, you count number of database, you count number of tables. Okay, also count number of external interfaces, connection to outside system. Okay, so calculate count total. Count total is here. Okay, so count total is here. First, you need to count number of user input. Look at all the screen, all the count number of input field, count number of clickable buttons, count number of clickable links. Okay, whatever can be input, you count. Okay, and give a number here. So count number of user, not count number of user output, count number of output fields, number of screens, number of reports. Okay, and write down the total here. So do the same for others. So weighting factor, simple, average, complex. So all these numbers okay, so all this number is determined by the company. Okay. So summation Fi. Okay, so summation Fi is total of 14 adjustment values based on 14 questions. So for this part, okay, you give a scale. Okay, so for summation Fi, there are 14 questions here. For each question, you give a scale from 0 to 5. So for this question, does the system require reliable backup or recovery? If the answer is no, then you give a value 0. If answer is yes, then you decide whether to give 1, 2, 3, or 5. Okay, so you answer each question, give a 0 from 0 to 5. There is summation Fi. So summation Fi, so the value is 0 to 70. So if all is 0, is summation Fi is 0. If all the answer is 5, then summation Fi is 70. So summation Fi, the value range from 0 to 70. Okay, so calculate function point. So to calculate function point, if let's say in exam, you will be given this one, you will be given this, you will be given this, You will also be asked to assume summation Fi is 60 to make things simple. So this is what you need to determine. Okay, so this one is count multiply weighting factor 2, 5, 10, 4, 2, 8. Then you sum up. You sum up these numbers, you get count total. You sum up this column, there is the count total. Okay, so now you can apply the formula. Function point is count total times 0.65 plus 0.01 summation Fi. Okay, so in this case, for this system, the total function point is 103.75. Okay, so if in exam or those past year exam, you are given this, you have to you are told to assume summation Fi is 60, then you apply the formula, you get the function point. Okay, so these are examples of normalized function-oriented metrics. So after you know the function point, you can divide errors by function point, divide defects by function point to make fairer comparison. Okay, another exercise. So you are given two projects. Okay, you are given two projects. So calculate the function point for project A and project B. So given this, and this, and you are asked to assume summation Fi is 60, so you should be able to determine the function point for project A and B. Okay, so function point for project A is 83.75. Function point for project B is 153.75. Okay, so pages of documentation per function point for project A is 1.43. Pages of documentation per function point for project B is 1.24. So conclusion is project A has more pages of documentation per function point than project B. So this means project A, you have more. For project A, you have more project information compared to project B. Okay, so hence project A has higher degree of maintainability than project B. So the more pages of documentation that you have, okay, so the higher degree is the degree of maintainability will be higher when you have more project information. Okay, so when you calculate function point, you see project A has 83.75 function point, project B function point in terms of function point is double than A. What does it tell you? Project B has more function point than project A. What does this tell you when one project has more function point than the other project? Okay, so when one project has more function point than the other project, it can tell us, in this case, it can tell us project B is more complex than complex. Project B is more complex than project A. Okay. In terms of size, project B is also greater than project A, because Okay, so when there are more inputs, when there are more outputs, okay, then there will be more function point. So when there's more input, more output, more inquiry, more files, there will be more function points. Okay, so more function points can mean the project size is bigger, the project is more complicated. So what is good about function point compared to lines of code? You should be able to determine the function point at this stage. After design is completed, after design is completed, you should be able to determine the function point. So lines of code,
1到4吧。
okay, so total lines of code, okay, after implementation.
一些答案不对。
Okay, so this means
要排。有点吵。
you can only determine the lines of code
我自然
when the project is completed. Okay, but function point you can determine at the early stage of the project.
往上排。
Okay, so if you know function point at the early stage of the project, then you will be able to accurately estimate amount of effort needed to do coding and testing. It will help you here. Okay, so lines of code can be determined after the project ended or late in the project. Any question? Okay, let's continue.
世界差不好。这发才有动力。这里睡觉。
Okay, so measuring software quality. Okay, so measuring software quality. So correctness. Measuring software quality. So how to measure correctness? So the definition for correctness is the degree to which the software performs its required function. Okay, so to measure correctness, you can count. Okay, so you can count number of defects per 1,000 lines of code or defects over a standard period of time. Okay, example 1 year or 1 month. Okay, so how to calculate how to calculate defects per 1,000 lines of code. Okay, so if a program has 100 defects, okay, so if a program has 100 defects and 10,000 lines of code, so you can calculate a defect per 1,000 lines of code is 100 over 10,000 multiply 1,000, that is 10 defects per 1,000 lines of code. So a program has 100 defects. Okay, so a program has 100 defects and 10,000 lines of code. So meaning in 10,000 lines of code, there are 100 defects. So you want to determine how many defects are there in 1,000 lines of code. Okay, how many? A simple way is to do this. So assuming this is x, so x is okay, so this is x. This multiply this multiply this. Let me show you one more step. So this means 10,000 x is equal to 100 multiply 1,000. So x is equal to 100 times 1,000 over 10,000. So this is what my math teacher teaches us. This is how my math teacher teach us. So 10. Okay, so this is how you calculate defects per 1,000 lines of code. Okay, when you are given total lines of code and total defects. Okay, so below defects per 1,000 line of code is increasing over time. This indicates software quality is decreasing. Okay, so 2021 project A, 2022 project B, project C. Okay, so A 10 defects, B 20, 25. So defects is increasing. So this gives us an insight. The quality is decreasing. So when quality, you know, when you measure, you will know. Okay, so when you measure, you know. Okay, so whether your quality is improving or your quality is getting worse. And if worse, okay, do something. Okay, so usability. Okay, so measuring usability, how to measure usability? So you can measure the time required to learn how to perform a task for the first time using the system. This is one way of measuring usability. Okay, example, record a Gmeet for the first time. You have not recorded Gmeet before. Okay, so you want to record Gmeet. Okay, first time. So how much time you spend to do that? Okay, so you can also measure the time required to become moderately efficient in the use of a system. Okay, so example, time needed to become moderately efficient in operating a car infotainment system. Do you have a car information system? So how good are you in operating your car's infotainment system? Okay, how much time do you need to spend to become moderately efficient? Anyone has a car and has an infotainment system? Anyone? Don't have. Yours is a basic car. Okay, when you get a new car with all the modern gadgets, I think you will struggle with your car infotainment system. Okay, you will struggle. Okay, and you may need some time to get used to it. You may also need to spend some time to become moderately efficient. When I go to the showroom to bring back my new car, okay, so I think the salesman haven't told me enough. Okay, after getting into the car, where to turn on the aircon? How to turn on the aircon? Forgot to ask this question. Okay, that's one of the problem I encountered. Also struggling with the infotainment system because using it for the first time. Okay, so to measure usability, also you can measure user attitude towards the system. So you can use questionnaire. Okay, so you can use questionnaire, give questionnaire to user. Okay, so when you get back the response, count the number of negative and positive responses. Okay, or you can also measure net increase of productivity. This one you read, this one you read. Okay, so challenges in measuring software. So what are the challenges? So measurement is complex. Okay, so measurement is complex, especially measuring function point. Okay, measuring function point is not easy. It's not easy. You have to understand how it works first. Okay, you have to understand how it works. What is input, what is output, what is inquiry. Okay, so make sure that you count the correct things. Okay, so very few professionals could understand, especially function point. So lines of code is easy. Line of code is also not easy. How do you determine this is one lines of code? Sometimes you can combine two lines of code as one lines of code, correct? Okay, so and the third changes is collecting measure is time consuming. Okay, so it is time consuming to count. Okay, how many lines of code you have? You have many programs. Okay, so in total, how many lines of code do you have? Okay, so it also hard to count. Okay, how many lines of code per 1,000 lines of code? How many errors are there in every 1,000 lines of code? Okay, so pages of documentation is also time consuming to determine. So that means you have to gather all the files, all the documentation, okay, and then sum up in total you have how many pages of documentation. Okay, so all this, collecting all this measurement is time consuming. Okay, so difficult to define what to measure and evaluating measure that are corrected. Okay, so when you are in project, also sometimes you don't know what you want to measure. Okay, so after measure it, how are you going to interpret what you have measured? Okay, so to summarize, I hope you can still remember what is metrics. Okay, what is measurement? Okay, so how to measure software quality, and these are the reasons why we want to measure. No, these are the things that we can measure, and the reason for measurement. Okay, and these are the reason for doing measurement. Okay, finish.
哇，终于吃饭了。
Do you have any question?
No.
Okay, so measurement is a measurement. It's good that you normalize what you have measured to do fair comparison. So for the car industry, they measure how many liters per 100 km. This is to measure fuel efficiency, to compare fuel efficiency between one brand with another brand. Okay, so for car industry, what else they measure? This is what we normally want to see. Okay, this is normally what we want to see when we buy a car. This is what we look at. Any other metrics that you want to look at before making purchase decision? Transaction amount per hour. What transaction is that?
没吹。
RM per hour for car or for what? Payment. When you want to buy a car, okay, when you want to buy a car, what are the metrics that you want to see? So when buying a car, we want to see in terms of fuel consumption. between two
以前我有没
brands.
有读啊？
One brand may says
可是我
one
忘记了
brand may says 8 liter
我
per
得读
100
啊。
km. Another brand may
看
give
你要
you
不要？
6 liter per 100 km. This is very fuel efficient. You may want to choose this. What kind of speed?
Something like km per hour.
Okay, yes, 100 km per hour in 5 seconds. That's measuring acceleration. How fast a car can reach this speed in second. Okay, so that's for car, but for software, this is what we look at. Okay, so for software, this is what we look at. Errors per 1,000 lines of code, defects. Okay, cost per lines of code. Okay, so if cost per lines of code is increasing, so if cost per 1,000 lines, cost per line of code is increasing, that means your software will be getting more and more expensive. So is there a way you can bring down the cost? Okay, so that's all for today. Thank you. Anyone here forgotten to take your attendance last week? I mean last week during lecture time.
为什么泡泡？
跑减没什么。
也180，其他的都要。
只有这个是满的。